the first thing we would do is match the speed of the asteroid. So if the asteroid were spinning, we would rotate the spacecraft to match the spin. If it's tumbling, that might be a bit of a challenge. So right now we're focused on slower rotating asteroids that rotate about half an RPM or less. Most asteroids are thought to do that in the size range that we are going after. Bigger asteroids mostly rotate about once every 2 hours. But as you get smaller, the spin rate goes up. And we believe that that half an RPM is a reasonable upper limit for what we're designing to now. We know that there are some small asteroids that spin faster than that, but we would like to know how fast it's spinning before we pick it as a target, so that we can pick one that is less than half an RPM. The thing about half an RPM that is good is that then we can keep up with the asteroid. Even if it is tumbling, we can spin the spacecraft at half an RPM, and as the spin axis moves in space, we can follow it using the little thrusters on the spacecraft, and so we can maintain essentially no relative motion between the asteroid and the spacecraft as we deploy the bag over the asteroid. Then we can cinch the bag closed, just like a trash bag. You pull the cords and the trash bag closes, and once you have forces applied by the cinch cords, then you can use the thrusters, again, these same small thrusters on the spacecraft that are used for attitude control. You can use that to despin the asteroid, and it turns out that it takes, just a relatively small amount of propellant. We carry 10 tons of xenon for the electric propulsion part, and we'd use a few hundred kilograms or a few tenths of a ton of propellant for the attitude control system to do the despinning.